All right, linear algebra. I just became aware that I forgot a grade, it looks like, some of my last problems. So I'm going to go and grade those first before we jump into Anki. All right, we got all of them correct. All the problems, so that's great. Let's go ahead and get back into Anki. We're going to have a lot of flashcards due, and then we're going to try to finish typing in the last 5, I believe. All right, we got 17 due right now, or 19 due right now. Assuming that A and B meet the size requirements to add and subtract, how might you compute A plus B and A minus B? For A plus B, you're going to add all the corresponding entries into a resulting matrix, and A minus B, you're going to basically subtract B from A in the corresponding, all the corresponding entries. Okay. Assuming A and B have the appropriate sizes, how might you compute the jth column vector and the ith row vector of AB without computing the entire product? So for the jth column vector, you're basically going to take the jth row of B. So you're going to take A times the jth row of B, or column, A times the jth row of A times the jth column of B. To find the ith row vector of AB, you're going to take the ith row of A times B. Good. All right. Good. If a homogeneous linear system has n unknowns, and if the reduced row echelon form of its augmented matrix has r non-zero rows, what can you say about the number of free variables in the system? You're going to have n minus r free variables, n minus r. Yep. Good. Wait, did that say reduced row echelon form? Yep. Okay, then that makes sense. What is the row column rule for computing A, B in parentheses and then sub ij? The row column rule is basically to find ij of AB. You're going to take row I from A times row j of B. Multiply row I of A by column. Did I say row? I meant column. And sum the products. Okay, again. I know some of the products, I forgot to say it. If C is a scalar and A is a matrix, what is the matrix CA? It's the resulting matrix of multiplying the scalar by every entry in A. Matrix obtained by multiplying each entry of A by C. Good. What is a matrix? Rectangular array of numbers. What is the linear combination of matrices? Essentially, it's going to just be the addition of a bunch of matrices together that are the same size and are multiplied by scalars. Expression in the form of C1A1 plus C2A2 plus ... plus CRAR, where C1, CR are scalars, A1 ... AR are matrices of the same size. I didn't say it exactly like that, but it's good. What is a column matrix? It's a matrix with one column. Good. If A equals bracket A sub ij bracket, what does A in parentheses capital A sub 22 or 22 denote? A22 denotes I, or basically A capital A in parentheses matrix A 22 equals A lowercase a sub 22. Good. What is a pivot column of a matrix? A pivot column is a column that contains a pivot. Pivot position, all right. I don't remember what the difference between a pivot and a pivot position is. What are the entries on the main diagonal of an n times n matrix? A equals bracket A sub ij bracket. What are the entries? The main diagonal is starting from the top left-hand corner down to the bottom right-hand corner. A11, A22, A dot, or dot dot dot, ANN. ANN. Good. What is a square matrix of order n? It's an n by n matrix. What does it mean to state that a matrix has a size of m x n? It means there's m rows and n columns. What is required for a sum or difference of matrices A and B to be defined? What is required for a sum or differences? They got to be the same size. What size requirement must be met for the matrix product AB to be defined? The number of columns in A must equal the number of rows in B. Good. Write out the matrix represented by the symbol A bracket AI bracket A sub IJ bracket sub 3 by 4 3x4. It's going to be a 3 by 4 matrix, and it's going to say A11, A12, A13, A14, and then it's going to go down 2 more rows. Good. What is the difference between Gaussian elimination and Gauss-Jordan elimination? Gaussian elimination, essentially, you're getting the matrix into row echelon form. Gauss-Jordan, you're getting it into the reduced row echelon form. Good. What is required for 2 matrices to be equal? They've got to be the same size, and all corresponding entries have to be equal. Good. What is a row matrix? It's a matrix with 1 row. What is the row column rule for computing matrix AB at IJ? You multiply row I of matrix A times column J of matrix B, and then you sum the products. Good. What is a pivot column of a matrix? It's a column that contains a pivot position. All right. So now we're good to go. We're caught up. Now we've got a few more flashcards to add from 1.3, but we should finish this today, and we should be into 1.4 today. So I'll be back in a little bit. Feels like a meme at this point how long we've been in chapter 1, section 3. Every time I'm like, we're about to be at 1.4, I feel like it's been a week or more. So I'm like, hopefully we'll be starting 1.4 today or tomorrow. I'm going to say it again. Hopefully we start it tomorrow. I've got 3 more flashcards. One of them took forever building out these huge matrices in a flashcard. That's why it took so long. But we have 3 more to do. And then we'll finally be in 1.4. So that's it for today. Talk to you tomorrow. See you.